Good morning, everyone. Thank you for joining us. First, I would like to thank Julie Carson and Jean McAvoy from the Immokalee IFAS Center for their help and cooperation. Today's programs offer 1 CEU for pesticide license renewal and 1 CEU for certified crop advisors. If you need CEUs, I am sure you heard Julie. So email Jean, your name, your email address, and license number. It's in the chat box. And ask him to send you your CEU form. Our guest speaker today are Chris Oswalt. He's a multi-county citrus extension agent in Central Florida, and Rick Lusher, director of the Florida Automated Weather Network, FAWN. The program today is about the citrus winter weather. The presentations will include information on winter weather watch, ag weather forecasts, freeze protection, FAWN, and cold protection and irrigation tools. Chris will go first. It's all yours, Chris.
All right, thank you, Mongi. Let me see if we can pull this off again. All right, are we there?
Perfect, Chris. Looks great.
Okay, all right. So thank you, Mongi. Appreciate the opportunity to come and talk to you folks this morning about basically Florida citrus in the winter. What do we do about it? What do we know about it? Some of the things that we would like to keep an eye on as far as winter weather and susceptibility of freezing temperatures to citrus. And so we're going to talk about a number of things, and I've got 30 minutes to do it. So we're going to try to move right through this. As Mongi said, I am the citrus extension agent for Polk and Hillsborough counties, and my name's Chris Oswalt. And if you all want to contact me, we can get my email out afterwards if you need to send me an email about anything you might have questions about. All right, we're going to talk a little bit about the Winter Weather Watch. That's actually an educational program we do up here in Polk County. It also basically provides forecasts at this point for West Central Florida. So we look at the forecast from Pasco all the way down to Immokalee. But really, this program started back in 1963, and it occurred because of the 1962 freeze. Because the freeze in 1962, we all used overhead irrigation, as this gentleman is standing by a tree that's covered in ice. So we were using overhead in 62, kind of gave us all a bad feeling about using water for cold protection. But the next year, they started the Winter Weather Watch, and it actually started in Polk County, started in Lakeland. They had an ag weather office in Lakeland, in the city of Lakeland, and they were providing ag forecasts. They had meteorologists at the time that were there. And one of the problems that occurred was back in the 60s, when you wanted weather information, it was often very difficult to get, because typically there were few television stations that were around that you could get, but you'd have to be there when the forecast came out, when the meteorologist did his presentation on TV. You'd have to be there to see that. The other way was AM radio. So back in the 60s, AM radio, with the exception of a few of, there's an AM station out of New Orleans and one out of Atlanta that blast all night long. Most of the AM radio stations that would have weather information, especially ag weather information, by the time sunset came, they were all off the air. So there was a need by growers to have this information. And so what the extension agents at that time did was they made arrangements to basically get a teletype machine so that they could get the actual weather forecasts that were being created by Lakeland and Ruskin. And they would get that information, and they would have the forecasts available so growers could call and they could get this forecast information. Because back in the 60s and 70s, if you needed to talk to a forecaster, there were only so many that would be on call or at the station at the Weather Service office at night during these freeze events, and they had a limited number of phone lines. So most of the time, if you were a grower and wanted that information, you basically got a busy signal all night. So this was a way to help address that. And this program has been going on now for this, I think, as I count, probably this is the 58th year that this service has been available to citrus growers in Florida in some form or fashion. And what we do is we don't do anything special. We provide National Weather Service information, and in our program, what we do is, in addition to having that information, which you can get, you basically have, or we have access to a retired meteorologist, Fred Crosby, who used to be the meteorologist in charge at the Ruskin National Weather Service office, or the Tampa Weather Service office. It's in Ruskin. And he was actually meteorologist in charge when they did a lot of this ag, when they were still doing ag weather type information. So those forecasts were coming out. Fred was there at that time, and Fred helps us during the winter in this program. In this program, actually, it's more than just calling up and getting a forecast. We do provide the National Service forecast information. You basically have two sets of eyes looking at this. You have Fred looking at what they're doing, and I also spend about an hour every morning putting together the National Weather Service information, taking a look at it so that I can stay on top of this to give you all a heads up if you choose to participate in the program. But in the program, we do a winter weather watch manual, and it talks about all sorts of winter weather related information as related to citrus. There is one chapter on blueberries, but a lot of it has to do with the susceptibility of citrus to freezing temperatures, the forecasts, what they mean, how to interpret them, and how you can use them in your program, in your citrus production program. And we also, as part of this program, provide information on citrus tree acclimation, which is the tree's ability to acclimate to colder temperatures. So as the winter progresses, they acquire this acclimation. We can measure it by doing leaf freezing temperatures, which we put on FAWN, and Rick may touch on this later. But we'll put this information on FAWN so you can see the amount of acclimation trees are receiving during the winter, give you an idea of how cold tolerant they may be at any given time, because that can range anywhere from, new flush, tender new flush that comes out, maybe 32, we'll get it, all the way down to, in most winters, we go at least to 20 degrees before leaves will freeze. So that information we provide, because it changes, it's dynamic over the winter, we'll provide that as part of this program. So it's not just the forecast, it's a forecast, it's Fred's looking, it's me looking, it's the winter weather watch manual, it's meetings like this, it's the leaf freezing information, and we provide that. And that's what I call the winter weather watch program that we do. And in Florida, what I try to do is we look at Pasco and Hillsborough, Polk County, Highlands, all the way down to Henry, Glades, Henry, and Eastern Collier County. And those are the areas that I look at every morning and look forward to in the next week or two with the forecast models, try to keep an eye on things for people. So you don't have to spend this much time hunting the internet looking for all these sites, because I've already got them in there. And I just go ahead and look up that information and provide it to you. So it's just a way to save a little bit of time, and you get a couple of other people helping you look at, what the weather forecasts are looking like in the near future. So now that kind of explains the program. That's one place where you can get weather information, agricultural weather information. But the question is, well, if you don't get it from there, where do you get your weather forecast, winter weather forecast information? Of course, you can. This one here I've used before, but it's an olive, and it's hanging in front of a hotel, and it's pretty simple. You hang an orange out outside your window, and if the orange is wet, it's raining. If it's not wet, it's dry. If you see a shadow underneath the orange, or in this case the olive, you'll know that it's sunny. And if you don't, then it's cloudy. And if there's snow on top of it, it's cold. Those kinds of things. But not really a good way to get your forecast information. It's basically real-time weather, and I think Rick does a better job of collecting that and providing it than this typical situation here with an olive. But the ag weather forecast, where can you get them? Well, over the years, I've pretty much figured out that there are private forecasters in Florida that will provide ag weather information. It's totally who they are. You'll have to find out for yourselves, because we don't recommend any specific service or individual, but there are private forecasters that do ag weather that will provide that information to you for a fee. There's also AWIS, which is the Ag Weather Information System, which is out of Auburn, which were at that time, I guess there still are, retired meteorologists out of Auburn that continue to provide ag weather information. And that is a fee service that you can sign up for. There's the Winter Weather Watch, which I just explained. You can get your weather information. Nowadays you have a phone, you got the Weather Channel, you got access to any number of different forecasts. So there's obviously the Weather Channel. your local news networks. You can get information from them. If you find that they're reliable and their information is consistent, which is real important, is that it's reliable information and it's consistent so that you can fine tune it for your specific location. And then of course there is a National Weather Service, and typically all the information, all the forecasts that are generated from data that the National Weather Service collects every day. So every sunrise and every at sunrise and sunset, National Weather Service launches a balloon. That balloon then collects data. That data is then put into the models that the National Service runs, which then generate the different forecasts that are fine-tuned for individual Weather Service offices. But that's where all the data comes from. So all these other individuals typically use National Weather Service data because nobody else is launching balloons. So that's where all the original data does come from, the National Weather Service. And that's basically what we pretty much provide. I mean, we're not doing any forecasting or anything special in the Winter Weather Watch program, just helping you do a better job, hopefully, of understanding forecasts and what they mean. Okay, so we're going to switch gears a little bit after talking about Winter Weather Watch program and talk a little bit about the types of freezes. I know I probably said this until I'm blue in the face, and some of you probably have already heard this, but I'm going to go ahead and do it because it's not rocket science really at this point. There's typically 4 kinds of freezes that we typically have in Florida. The first type is what we call an advective freeze, and that's when the front first moves through and it clears out through the area and the center of high pressure is not over the state of Florida yet, or has not moved down to where it's going to settle. You get the winds blowing and you get a linear fall in temperatures overnight. And so that's what we call an advective freeze. It's pretty straightforward. The wind blows and you're going to have a linear drop in this temperature. The other type of freeze that we have is a radiation freeze. And radiation freezes typically happen after the advection of cold air comes in the first night, with an advective freeze. And then you have the radiation situation where you have calm winds, clear skies. You get a rapid drop in temperature after sunset. Typically 2/3 of the drop will happen the first half of the night, and then the last third will happen the second half of the night. That's why it stays cold longer in these types of freezes. So that's typically the characteristic of that. The break is what we call, typically starts off like a radiation freeze, but then what happens is sometimes during the night, that center of cold air or high pressure typically may start to drift off. And as it drifts off, the winds will start to shift out of a northeast direction. And that typically is what we call a break, because once that stays consistently out of the northeast, you get moisture coming in off the Atlantic, and that kind of slows down the temperature drop. And actually you get a curve like this where your minimum temperatures actually occur before sunrise rather than what you typically see in the radiation or the advective freeze. Then the last one is kind of what we call the unsettled condition. Again, this typically is going to start off like a radiation type event. And then what you may have, you'll have clear skies, calm winds, and then you'll have cloud cover or cirrus clouds that move over, and that will slow the rate of drop in temperature, may even raise the temperature as in this graph. So you get either some winds picking up or you get some cloud cover moving over, and that will kind of mess with the typical radiation curve. But then if those conditions move out and then it goes back to calm, then you can go ahead and drop like you typically would in a radiation type freeze. So those are kind of the types of freezes that I think we associate with Florida and Florida citrus. So when we look at these forecasts, and what I like to do is look at the interpretation of this, because these are National Weather Service forecasts, so they're not going to do anything for ag. But what you got to do is you really need to pull out the information that is important to your forecast in your area and to the crop that you're growing. So in this case, we're looking at a National Weather Service forecast. This happens to be one that I've used before. But typically what you look for is you look to see what the conditions are. And so today it says, in this particular forecast is mostly cloudy, and then it's going to become partly sunny. There's a chance of showers, highs around 70, north winds. Nothing particular here other than it's going to rain. Sounds like a typical day. Then the next night, or it says tonight here, you'll have mostly cloudy with a chance of showers in the evening, partly cloudy after midnight. The lows are going to be so-and-so. The winds are going to be north of 5 and chance of rain 20%. So it's kind of being cloudy. So you kind of get the situation where, it's going to be warm and then you're going to get some clouds. It doesn't look like there's much wind. The winds are less than 5 miles an hour. So what does this look like when we're going to look in the next slide, I'll show you the graph. But then Saturday, it's saying that it's going to be mostly sunny, then become partly cloudy. It's going to be breezy. And then the winds are going to shift out of the northwest at 10 to 20 miles per hour with gusts to 30. So that means the cold air is coming in. Then Saturday night, you have it clear, colder, and you're going to still have that northwest wind. So that's telling you today's okay. Saturday, we're going to have a front coming in. So let's see what that looks like when you look at the graph. Okay, this is the first part of today, and you can look here and you can see where the temperature there, the maximum for the day is about 60, 66, 67 degrees. And the other lines there are actually the wet bulb temperature and the dew point, which is going to be important later on. And Rick's going to talk about some more of this. But you see the forecast, you get the warm temperatures during the day. You didn't have much wind, so you get some radiational cooling that night, but it's not a freeze. It's not cold air that's moved in from somewhere else. And you can see where it drops down at sunset, the temperatures drop, and then they'll start to come together there, and kind of the dew point, the wet bulb, and the air temperature will all kind of hang together there in that particular situation around sunset. And you'll get some bouncing around where you see all three of them go up. That might be some clouds that are coming in, or maybe some, you know, it said there was still chance of rain. So that might be what's happening there. All right, so now we go to the next day. So the National Weather Service forecast says there's a freeze warning in effect Sunday, and then a freeze watch in effect from Sunday night through Monday morning. So now we're going to look at the next day, which was when the freeze was coming in. It's going to say partly cloudy, then mostly cloudy early in the afternoon, then becoming partly cloudy, a slight chance of showers in the afternoon. Then it's going to be breezy. It's going to be highs in the upper 60s, northwest winds 10 to 20, gusts up to 35, rain chance 20. That's probably early on. The freeze is coming in, the front's moving through. Tonight, you'll see partly cloudy, a chance of showers. In the evening, breezy, cooler, lows significantly lower than the night before, 30, 34, northwest winds. So the wind's going to blow and go north around 10 miles an hour after midnight, gusts up to 35, chance of rain 20%. So this is telling me what's going to happen is it's going to be an advective freeze. So what's going to happen is you're going to see potentially what you should see is a linear drop in temperatures. And then you're going to see Sunday, they're going to roll in and they're going to say the winds are going to be gusts up to 30 in the morning, then they're going to die down on Sunday night. So we'll talk about that here in a minute, but let's look at today and tonight, which is an advective freeze condition. So you come in here and then here's the high temperature for the day. It's lower than the previous day. And then you'll start to notice one of the characteristics of this too, this advective freeze situation is you get a difference in the air temperature, the wet bulb temperature, and the dew point temperature. And what those happen is they separate out as this cold air comes in, and you can see this pretty much a linear drop in temperature till sunrise, and that they don't come together because the wind's blowing in that cold air. So those three temperatures stay far apart, and that becomes important, the wet bulb temperature, when you talk about cold protection. But this is interpreting the forecast. So when you have an advective freeze, these lines are not going to be close together. So they're going to be far apart, and you're going to see this drop in temperature. All right, then we roll into Sunday night. So we got a high hard freeze watch in effect. Today, mostly sunny, cooler, highs in the mid 50s, north winds around 10. Tonight, mostly clear, lows 25, 29, light winds. So that's telling me, to me, the highs are only going to make it in the mid 50s, and it's going to be cold in the morning, and you're going to have light winds. So that's typically going to be the radiation type freeze condition. That says Monday, mostly sunny. So it's not talking about any clouds or any shift of any winds or anything. So I'm thinking it's going to be a typical radiation type condition, and then it's going to warm back up, and the lows on Monday night are going to be 45, 49. So tonight we're going to look at 25 to 29. We're going to see what that looks like. Should be a radiation. And if you come down and you look at this, you can see the cold air has moved in, and then during the day you have the high maximum temperature is only about say like 52. And if you'll notice down the green line on the bottom there is actually the dew point temperature. When dew point temperatures get in the teens and single digits, that's bad news. And in the middle of the afternoon, that's typically when those dew points are going to be lowest. So this kind of gives you a glimpse at potentially how cold that air can be or will be when it gets here. So you're looking at those dew points that low, and you see this big separation. Okay, that's what's happening. The freezes come in, the center of high pressure is starting to settle over, and now we're going to look and see what happens overnight. So overnight, you look here and you see where sunset is, which is about 6:15, and you'll see how fast the air temperature drops in a relatively short period of time, from maybe like 6:15 till 10:15. In 4 hours, it's about 2/3 of the actual fall in temperature is going to occur that quickly. And then the balance of that fall is going to be overnight. And if you notice, you start to see the wet bulb, the dew point, and the air temperature, they'll start to come together. And that means that the winds are typically that means that the winds are calming down and you're starting to get that radiation condition. And then they eventually reach that point. And then we'll talk about a little bit about what happens when they reach the dew point in that situation in a couple other slides. But that's basically the characteristic of what a radiation freeze would look like. You don't get that separation of those temperatures when you have a radiation condition like you do with the advective type situation. All right, so talk about freeze protection of citrus. Typically, we put them into two classes, passive or active. Passive, you're going to do prior to freeze. If you're not going to do anything at that point, it's already done. There's nothing else to do. Those are passive practices. Active are practices that you would do during a freeze. All right, the passive practice, typically we call those something like site selection. That's knowing about the historical data, weather data about your site. Could be elevation, higher elevation, typically cold air drains off of those. You stay out of the lower, colder areas. Windbreaks can slow the wind speed, can help you do a better job of cold protection because you're going to slow down that advective wind. Being on the south or southwest side of, southeast side of large bodies of water is a passive practice. I mean, you don't do that the day of the freeze. Your grove is going to be sitting there, but that's a conscious decision you make ahead of time. But these are the kinds of things that are passive. Other ones would be horticultural selections. And what we're talking about is choosing rootstocks that have more cold tolerance than other rootstocks, scions that may be harvested before the threat of cold weather. Row middle management is somewhat important in as much as it's related to keeping a nice low turf during the winter in those row middles so that sunlight can come in during the day and can help store some of that solar radiation for release overnight in certain freezes. Nutrition is important from the standpoint of there's no specific nutritional mineral element that's going to make the trees any more cold hardy, but if they are hungry or if they are stressed, they're going to be more susceptible to cold. And so you want to make sure that the trees have adequate nutrition. Irrigation, the same kind of thing. You don't want to over irrigate the tree and over fertilize it so it's vegetatively growing during the winter. You want that tree to acquire some acclimation, slow down, and withholding some water without stressing the tree can sometimes enhance that acclimation process. You can also, if you have young trees in a mature grove and you don't want to necessarily want to run the water for the whole thing, for the whole block, you can use some of these young tree trunk wraps that we used to use. Not many of them out there. Most of them are sprout inhibitors, but those wraps, their effectiveness is directly related to their insulating capacities. So if they're not a very good insulator, then they're not going to be a very good wrap to use for cold protection. So that's just something to keep in mind with some of these other ones that are out there that are really sprout inhibitors, not cold protection tree wraps. So some of the active practices would be grove heating or using heaters. We no longer do this. That used to be one of my pastimes when I was in high school. To get out of school the next day is you could go light grove heaters and that would get you a free pass for the next day. Well, we don't really use grove heaters very much anymore. This actually was one that I got out of a scion block out of a nursery because they were still using heaters to protect the budwood. There's also wind machines that have been used, but their use is directly related to the type of freeze. So when we talk about ag forecast or forecast, what does that mean? Well, if you're going to have a wind that's going to blow all night, why are you going to turn on a wind machine? So wind machines are going to work during radiational freezes. So you're looking for those keys that are going to tell you the winds are going to die down. So my wind machine, if I crank it, will be effective. But again, that's a technology that's still out there that is used to some degree, but it's specifically for radiation kinds of condition, radiation type freeze conditions. Most folks are going to use irrigation. Most folks are going to use microsprinkler irrigation, especially in citrus. All right, some of the things that we talk when we talk about microsprinkler irrigation, some things to remember is if you want to get the maximum amount of protection, you want to place that microsprinkler on the north or northwest side of the tree. You want it within 3 feet. You typically don't want a 360 emitter. You want something like a 90 degree or 180. What is important, at least in my experience, is it's the precipitation rate, the inches of water per hour that you can put on the tree. That's important. So if you have a 360, it's going to put out X amount of water. But if you use a 90 degree, it's going to put out 4 times, because the same amount of water is going over a smaller area. So you get a higher precipitation rate, and therefore typically more protection, because you're directing more water at the tree. But with water, or with irrigation, you have to be concerned about evaporative cooling. And that's what we were talking about with those 3 temperatures, the dew point, the wet bulb, and the air temperature, and how they're related and what that means to a grower. So this is the different states of water typically. And this is what actually does the part of protecting a tree or protecting crops from freezes when using water for cold protection. Okay, when water condenses out of the air, so when you have water vapor in the air and the surfaces and the air temperature and the surface temperature reaches the dew point, you have water condensating out of the air. That particular phase change of water vapor to liquid water will gain you about 9,000 BTUs. The part about that water freezing to ice is only going to get you about 1,200 BTUs. So the big jump is when it goes from a vapor to liquid. But what we typically do is go from a liquid to ice, and we keep doing that so that we maintain a temperature in that irrigated pattern on that tree that's getting this water that is continually freezing, that is releasing this 1,200 BTUs of energy, of heat. So you can see where that gains you heat. If you go from water vapor in the air to water vapor as a solid, you go through that and you get that heat. But what happens in evaporative cooling is you have a solid, which is ice, that skips the water phase and goes to the water vapor. It's physics, so you don't gain any more or lose any more heat. But what it does is it goes straight from a solid to a vapor, and you'll lose that number of BTUs, add them together, over 10,000 BTUs that you're going to lose. So that's going to cool rather than heat, and you're going to lose heat. And sometimes that can equate to being below your critical temperature. And so that's important when you're using water for cold protection, that you can do more harm than good if you don't understand the part of this. That is, you got to continue to generate heat, not lose heat, generate more heat than you lose. And this is one that I did a number of years ago, but typically what it is, I took 2 probes and 2 data loggers, and I froze them in a cup of water. Okay, so they're freezing a cup of water. This up here is 90 degrees. That's how hot the water was when I put it. Then I put it in the freezer. You can see where it drops really quick. It goes down to 32. It hangs around there for a while. Doesn't really do much. You can see there for overnight. Basically, it's in the freezer. It hangs at 32, and then it actually does finish freezing, and then it actually assumes about freezer temperature, which is down here around -5 degrees. Okay, what I did then was to demonstrate what evaporative cooling can do. Is if you look here, I take them out of the freezer, put them in a container. I took them to another program that I was doing. Then I set them there, and in one of these blocks of ice, I took it out of the cup, set it on 2 paper plates. One of these blocks of ice, I actually put salt on. And if you notice, it's the one with the orange line, because the act of putting salt melts that ice to water, and you lose heat because you're going from a solid to a liquid. You lose heat, and you can see where the one that stayed at air temperature didn't lose any heat, but the other one went from 32 degrees down to almost 10 degrees. So you lost all that heat by that ice melting. And this demonstrates what evaporative cooling can do. And this isn't even going to the vapor. This is just from a solid to liquid. And when you use micro sprinkler irrigation, this is a quick slide of where we looked at it in a particular block where we had micro sprinklers under mature trees. And you can see in the first night, December 13th and the 14th, you can look here and you can see the graph, how those temperatures inside and outside the tree canopy, pretty much outside the block and inside the tree canopy, they mirrored each other. They pretty much went down same temperature overnight. That's when the wind blows. And you can see the graph below it is the actual wind speed. So you can see the winds are picked up. And then the bottom graph down here is the difference between the outside and the inside. So how much protection are you getting? So in the first night, you can see you're probably not getting much from using irrigation because the wind's blowing. And in a mature tree where you have a bigger canopy. Now, when the winds die down on the second night, you can start to see that there's a difference between inside and outside, and that temperature can be almost, well, in this particular instance, it's 4 degrees. So you're getting 4-degree benefit from running the micro sprinkler underneath a mature tree under these particular conditions and those micro sprinkler emitter, the pattern and the gallons per hour. And then the third night, you can see it drop down, and you see some stuff going on here. You can see where the wind picked up early in the morning, and then you can see what the difference is there in as much as what kind of protection that micro sprinkler does. So it works fairly well. You get a lot more benefit from that when the winds are not blowing as hard. All right, and this just demonstrates the difference in the risk of evaporative cooling. If you look here, the difference between what we were talking about, the air temperature and the wet bulb temperature, the dew point is always lower unless it's a radiation freeze and they all come together. So typically what we look at is the wet bulb temperature, and that's the temperature that a wetted surface will become due to evaporation. So if you look here, you can see that moderate, strong, high. So the bigger that difference and the more the wind blows, the more evaporative cooling you're going to have and the more potential for damage you might have. And I think this might be my last one. Better hurry up and get done. And this just shows another freeze example with the air temperature, the wet bulb, and the dew point, and also shows a critical temperature of 32 degrees. And to demonstrate the part about evaporative cooling, if you look at the first night of this event, you can see where the wind blows, so it pretty much comes straight down like a line, a linear line. And you can see the differences between that dew point, wet bulb, and air temperature. They're greater there. And if you look at the air temperature, which is the blue line on top, and you look at the wet bulb, which is the one in between, you'll notice that the wet bulb temperature actually goes below that red line. So if you are not freezing more water than you're evaporating, then you can assume that wet bulb temperature, which is below your critical temperature. So you need to understand that, in as much as in this case, if you knew all these parameters, you wouldn't, if you didn't run the water, you would only get to basically 34 degrees. If you ran the water and the pump shut off, something happened, you could have gone to 28. So this part of evaporative cooling and understanding that wet bulb and the type of freeze is important so that you can make those judgment calls. The next night, it's still blowing in because you still get that difference, and you can see where the air temperature goes below your critical temperature. So that's kind of like a no-brainer. The third night, you can see where it's more of a radiation condition, because now at sunrise or overnight, you start to see all three of those temperatures come together. So that means it's relatively calm, and you're not going to have a lot of wind, so you're not going to have a lot of evaporative cooling. And that's it. And I only went over 2 minutes. So if anybody has any questions.
If anybody has a question, go ahead. Unmute yourself and go ahead. Or feel free to put it in the chat box.
All right, let me, am I stopped now? Have I stopped? Okay. I couldn't find all the right buttons.
Thank you, Chris. The second presentation will be given by Eric Lusher. He's the director of the Florida Automated Weather Network, which is FAWN. Go ahead, Eric.
All right. Thank you, Mongi. I appreciate that, and certainly do appreciate the invitation to come speak today.
You are welcome.
Yeah. So what I'd like to do today is to so you heard a lot of the conceptual cold protection related things from Chris, and I'm really glad he does that part because I found, since I've come to UF, even with a meteorology degree, nobody understands freeze protection and the conceptual aspects, in my opinion, better than extension agents and growers. And so there was a lot of this kind of stuff that I learned myself when I came on board with FAWN and UF and started working with so closely with extension and growers. So I'm really glad that he always agrees to do that part. So what I'd like to do is kind of like Chris was saying, probably a lot of what I show is going to be review for many of you. But we released a new look and feel to our website, kind of right in the middle of the early days of the COVID restrictions and all. And we were just kind of finishing up a complete renovation to our website. And so what I'd like to do is go over some of that with you, some of just the new look and feel with you, but also to focus on the freeze protection tools and some of the other citrus related items. So, you know, as you all probably know, FAWN, this is kind of an overview of what we provide, data, and we don't do the forecasts, but we provide the forecasts from the Weather Service, which sometimes, you know, I think that forecast olive, you know, might actually do about the same job, but because that's just a very, it's a hard, forecasting is hard. And freeze protection, you all know that. That's kind of how we got started. Irrigation as well. And then we have a forecast tool for chemical application. So just a few slides that show an overview of our new website. You may remember before that we had a pretty basic map with the temperatures on there, and you could mouse over the temperatures and so on, but it was all, the map itself was pretty static. You are using some GIS technology now so that you can zoom in and out of the map. As you can see from this slide, you can put the rainfall on the map. You can also show the counties on the map as well. So you have some more flexibility now with what you can look at on the map. And so you can see the stations there with the temperatures. Down at the bottom of the homepage, we have selections for the kind of the most used pages. So latest observations is always one that people look at. And this is based on the Google analytics that we look at for the website. Graphical weather data has always been one that's heavily used. And then you have some other selections there as well. And that's down at the bottom of the homepage. So now going across the top there, so data access tools and so on. If you go to data access, you have all the ways that you can access archive data. So you have the air temperature threshold, which is kind of like chill hours to some degree, in that it shows you the number of hours the site was above or below a specified temperature. The graphical weather data I mentioned before. The report generator is if you want to go download any archive data in a spreadsheet format, you can go to the report generator to do that. Now the report generator is for relatively short periods of time, and so that's kind of to minimize server resources. So you can't go in and download 5 years of data from a site using the report generator. But if you wanted to get, like, say, a month's worth of current temperatures or something like that, the report generator is good for that. The data feeds is for programmers to get real-time data. And then the FTP are the larger CSV files that have data. So if you do need 5 years of data, you can get that from that link. So going across, you have the tools. So we kind of organized. One of the things we tried to do with the new website is to organize everything so that you can quickly access the different tools that you need from these drop-down menus. So if you mouse over cold protection there, you get the complete list of cold protection tools and so on down the line. More is just the extra stuff, about FAWN, technical information, shows you the different kinds of sensors we use and that sort of thing. So now going back to the homepage map, if you click on one of the stations or you mouse over one of the stations, over on the right-hand side of the map, you get just a kind of a quick display there of the main parameters that people look at when they're looking at a weather report. So anytime you think, oh, I want to check the weather, usually you're thinking about the air temperature. You're thinking what's the rainfall been like, the relative humidity and that kind of stuff. And so we show that right to the right there. And then if you click more at the bottom of that, it takes you to what we call the station page. So everything about that station is there. The complete weather observation, and then at the bottom there is a multi-day forecast that we bring in from the Weather Service. So what I'm going to do now is I'm going to go right down the left side of the page there and just show you the different things that appear when you click on those. And so the first thing is the graphical weather data. And what we've tried to do with this new website is to put everything, like all the calculations that we do for one station, we've tried to display them on the same page. So if you might remember before, you might have to go out to tools and then go look at some other tool for that station. And you're going through multiple clicks and pages and things to get there. Well, what we've tried to do now is to make everything accessible for, in this case, Alachua, which is the station that's here, from this page. And so that's kind of what we're doing with the left side menu there. So graphical weather data is there. The graphical forecast is there, and you can see from the drop down the different parameters that you can look at for that. Wind speed, humidity, precipitation, and wet bulb. Any weather advisories that are in effect for the area that station is in will show here on this. And if there's more than one, there will be multiple tabs, like you see hazardous weather outlook. There will be multiple tabs across the top there so you can click on each type of advisory that's in effect. Chill portions is similar to chill hours. It's this tool was created mainly for blueberries, but it's the chill portions is based on the dynamic model. And then we have cold protection, which is what I'll kind of focus on here. And so what we've done is we've displayed all the cold protection tools right on this page. So you can just scroll right down. Everything is for the station that you're looking at. And so we have the graphical forecast that appears first. And so anytime you're thinking about cold protection, you're kind of thinking, okay, well, what's the general forecast going to be for the next few days? And that's what this graph shows here. And this whole graph is brought right in from the Weather Service. And so it's just, we didn't do anything to it except bring it right in. And you can scroll to the right on this map as well to look further into the future for temperature, which is at the top, wind speed and direction, which is in the middle, and then rainfall, which is at the bottom. And then, so that's the first thing. The next thing is the minimum overnight temperature. And so just going right down the page, you can see the heading right at the bottom of this screenshot. And this is what's right below that. And so we have the, on any given cold night, you would look at the estimated overnight minimum temperature, which uses the Brunt equation to estimate that. And so you've gone from the larger scale forecasts of several days down to saying, okay, tonight it's supposed to be cold. What does the Brunt equation say that the overnight minimum temperature might be? And so you have that right there. And if you look right below that, where it says more information, every tool that's on here, you can click a link there and it will give you some background information on, like, how was the tool created? How does it calculate and that kind of stuff. And so every tool we have there, you can click that. The next thing down is the forecast tracker. So as you're going through an individual cold night, how is the forecast comparing to what's actually happening? And the red line there shows the critical temperature, which you, and I actually overlooked that, my apologies. At the top of this page, you can see first set your critical temperature set, and then throughout that page, it will use that critical temperature just like it does right here, although I changed it to 60 just for this presentation so that you can see kind of how it works in a real-time setting. You know, you can look at, you know, how are the temperatures approaching the critical minimums for my crop. And one of the unique things about the forecast tracker that we believe makes it so useful, you can see as both of the temperatures get kind of start to dip to the lowest points, there's quite a bit of separation between the forecast, which is the blue line, and the actual temperature, which is the black line. And that's exactly why this tool was created. So, you know, you can see the forecast, you know, the critical temperature that I put on here, which is 60, the forecast is way above that, but the actual observations dip down below that number. So if you're looking at the NWS forecast, in this case, you would see, well, they're not expecting the temperatures to get down to my critical number, but as the night goes on, you can see that the actual numbers get down below that number. So that's exactly why this tool was created, so that you can see how well is the forecast doing compared to the actual observations. And below that chart is a table. I don't show it on here, but there's a table that shows you the actual numbers as well as the graph. So if you want to look at the hard numbers, you can look at that as well. So the next thing down the line, and what Chris mentioned, is this evaporative cooling potential, which is, you know, what's the potential minimum temperature if you factor in evaporation. And that link there that says view irrigation risk criteria, that's the same chart that Chris showed you in his presentation. So if you click there, you'll see that same chart. And so you have the current irrigation risk, in this case it's none, and then air temperature, wet bulb, and wind speed. So the idea is if you have high wind speeds and you have a large difference between the air and wet bulb temperatures, you have potential for evaporative cooling. And then finally, you have the irrigation cutoff temperature. And so if you have a running irrigation system, what's a safe temperature at which you can turn your system off without risking further damage due to evaporation? And so we give you that safe cutoff temperature. And again, there's more information on that link there. So that's an overview of the cold protection tools. And again, they're all right on that station page. You can scroll right down the list there without having to go out and around and come back to it through the tools menu, although you can get to it that way if you want. So the next thing down the list is our crop irrigation schedulers. And you may remember previously, again, you had to go to tools, irrigation schedulers, and you had to go through the crop and all that. Well, here you can get to them right on this page. And if you look across the top, right above the title, Citrus Micro Sprinkler Irrigation Scheduler, you see you have multiple crops that you can choose from. And so you can get to all of the crops right on this page, put in the information, and it will give you a recommended schedule. And then at the bottom, I don't show it on here, but location info just simply shows you information about where that station's located, the latitude, longitude, and different things like that. So, that's kind of all I have for the website. What I'd like to talk about now for just a couple of minutes is just some of the things that we're working on as we move forward. And so it's been kind of interesting. You know, for so many, at least my impression is that during the COVID, when we kind of all started working from home and doing different things, we actually got substantially busier than we were before, which to me is certainly a good thing. And some of the things that we are working on for the future are adding soil moisture sensors to our stations. And we became involved in a multi-state grant, again, kind of right at the beginning of COVID. This came up, and we, along with the states of Georgia and Alabama, submitted a grant to NOAA to add to the soil moisture network in the Southeast, and got that grant. And so over the next year or so, maybe a little bit longer, we're going to be adding soil moisture sensors to all of our stations. And so we're kind of in the process right now of testing some different ones, and kind of with the other states to see what's a good sensor we can use that doesn't cost an arm and a leg. And so we're kind of working on that right now. And here is an example. This is actually a sensor we already have installed at Immokalee. And you can see on the left there, you can select soil moisture, and it will show you this particular one is a 48-inch sensor, so it's 4 feet long. But you can see the depths that are shown kind of by default there. And also on that is the rainfall that occurred. And so you can compare those two, and you can look at deeper depths as well just by clicking on the numbers that are grayed out. And then also at the bottom is the temperature. And so we won't put in 48-inch sensors at all the stations, but they'll be at least 24 inches long. And so that's an example. And I think we have 3 installed now that are on the website, but we have 5 total installed. The other 2 are not on the website yet. The other one in South Florida is at Belglade. We just don't have the data on the website for that one yet. Another thing, redundant rain gauges is kind of an ongoing project that we work on as we have time. So that's kind of a slower project that we're trying to do, just to have 2 rain gauges at each site, partly to quality control one another, but just to provide backup data just in case. New sites, I'm going to show you a map. And then we're working on some database, QA/QC, kind of new database format and structure that allows us to do some more sophisticated QA/QC, which we've needed to do for quite some time. And part of that will be like, say you go to the website and download data, it will give you a flag if there's some questionable measurements. So that's kind of what that's all about. And then finally, the new sites that we have planned, you can see with the blue dots on this map that we have quite a few new installations planned. And so we're working as fast and furiously as we can to make those happen. If you're a user of the Frostproof site, do not worry. We are working on a new site there. We had to remove that tower due to construction. And you can see those 2 blue dots that are real close to each other. One of those will be a new Frostproof site. And we hope to have that up in like the next month. And so we've got quite a few new sites, soil moisture, and some other things that we're really excited about. And with that, I will wrap up and thank our funding sources. We get about 70% of our budget from grants. And so we greatly appreciate those. And there's our website if you don't know it. Just a Google search for FAWN, it usually comes up at the top there. And with that, I finish, and hopefully on time.
Thank you, Rick.
Let
I
me
don't
see if
see
I
any
can get
question in the
my,
chat box. If anybody has a question, please go ahead.
let's see.
Yes, fire away with questions, or if you'd rather type them, put them in the chat box. I also just put the information in there again about contacting Gene McAvoy with your CEU and CCA license number information. His email is gmcavoy@ufl.edu. He'll take care of your materials for you.
Any question? It looks like we are lucky this year. We did not get a hurricane in our area. Hopefully we won't get a freeze. What your expectation, Chris?
Well, if historical information is correct, the fact that there's somewhere around a moderate La Nina bodes well for us, because neutral conditions are typically neutral or near neutral. El Nino conditions, La Nina conditions are when we typically have our major freezes. But with a moderate La Nina, that should be good news. I'm not saying it can't happen, but I'm just saying historically, at least those from 1980 to 2000, the data that was looked at more or less demonstrated that if you had a prevailing El Nino or La Nina condition, the chances were a lot less than if it were neutral. So that's kind of a plus.
If anybody needs to sign up for the winter weather watch, check my newsletter, the November issue. I have the information for you to sign up, or you can get in touch directly with Chris. One more chance if you have a question. If you don't, then thank you very much. Thank you, Chris and Rick. Thank
You're
you,
welcome,
Julie.
Mongi.
My pleasure. My pleasure. Thank you.
Thank you all for your participation. And again, if you are interested about CEUs, email Jean McAvoy, your email address, your license number, and what else? Your name. Don't forget your name.